will be Nikita Ostrovsky. I believe I got that right. And he will be speaking to us about how to usher in a new monitoring system into a company, and in this case, his company.
Hey guys, can you hear me okay? Too loud, too soft, too annoying? By the way, I have a ton of war stories for you. If I can give you an encyclopedia if you want. Either way, my name is Nikita, and I'm here to talk to you guys about how to usher in a new monitoring system. And I'm going to try to stay as non-technical as possible, because the fact of the matter is almost every solution that you look at, almost every possible monitoring system out there has more documentation than we have time for. So really, I'm going to try to work on a lot of the political battles you're going to fight, and a lot of the social issues you're going to have, and a lot of the problems you're going to face as you start to implement that. So a little bit about me first. Like I said, my name is Nikita. I'm a DevOps data architect at Pulsepoint, and what that means is I'm really focused on delivering data solutions and data-driven solutions, as well as monitoring for the data team and for the company at large. So at Pulsepoint, the data team pretty much owns monitoring, and that the reason being is because we believe that metrics and monitoring is a very data-driven thing. So, is this too quiet? Okay, good. All right. So metrics and monitoring is a really data-driven thing. Some background, I've been doing monitoring and SRE work for the better part of like 10 years. And I've had 3.5, I'd say, like of these massive type migrations where you go from something like Ganglia to Graphite, or you go from something like Nagios to Prometheus, which, by the way, don't ever do. Like, that's a huge jump. Don't do it. You'll freak your users out. A little bit about Pulsepoint. We're a real-time ad exchange. We handle about 40 billion impressions a day, about 150 billion bids per day. And like I said, what I really work on is log aggregation and Prometheus, as well as some queuing systems and some modern like SRE type work. We are hiring, by the way. We're hiring for like a DevOps-y type DBA. We have like a hole with some of our relational databases, and we're also hiring a developer. So please come see me, because we're like desperately looking for people. So before we talk about how to build out a new monitoring system, let's talk about why. And by the way, there's going to be a lot of D&D pictures here. So if you guys don't know what these monsters are, I apologize, but this is a beholder. So long story short, why do you want to have a new monitoring system? There's tons of benefits, tons of reasons. The first one is alerting, but not just alerting, sane alerting. You really want to be looking at about like somewhere in the 75 to 80% signal to noise ratio. And what I mean by that is when you receive an email, there should be a 70 to 80% chance that that email is actually actionable. It's something that you have to do. And you want to try to approach 100% as fast as possible. Some people kind of take the approach of like, well, my email is going to be my repository of data. That's not going to work. Absolutely not. You need to have as close as possible to 100% for your signal to noise ratios. But we'll talk about that a little bit later. Another really big benefit is troubleshooting. So we started taking metrics out of Jira at 2 of the previous places that I was at. Well, the current place and the previous place. And we've noticed that if a team has spent more than 1 sprint on dashboarding, they have roughly about a 300% faster remediation time in time of crisis. So not from the time you get the email, but rather from the time you start working till the time you finish your problem, it is 300% faster if you've got a relatively decent amount of time spent in dashboarding. So this is really powerful and something, as far as I'm concerned, is a huge sell to your CTO. Also, monitoring systems are really helpful for capacity planning. It's really nice to be able to tell your CTO, hey, if you give me 14 more Redis machines, I'll be able to increase my the system's capacity by 36% or something arbitrary. And having a modern, powerful monitoring system is going to let you do that. Also, bottleneck tracking is really, really valuable too, right? What is my bottleneck? Is it network? Is it memory? Who knows? And that's really really key when it comes to figuring out, like in that 10x meeting where your CTO tells you, I need to know what happens if we scale impressions by 10x right now? That's the conversation you need to have, and the way you prepare for it is by having a relatively sane metrics and monitoring platform. A lot of teams that are at Pulsepoint now are starting to integrate their monitoring system into sprint planning. This is really beneficial because a lot of those alerts, we call them quiet alerts. They just live on a dashboard. Nobody knows about them until they look at them. So we try like once a month or once every 2-week sprint to just go over them and see what are some of the big pain points that we don't necessarily see because of our monitoring system, and how can we plan our sprint around being able to alleviate those. But long story short, as you build out your monitoring system and as you understand it, you're going to realize that it really becomes the core of your tech stack. It's the central place most conversations have to do with monitoring, even if they're something completely unrelated to monitoring. And you'll notice this more and more as more and more users start to implement some of the monitoring solutions you deliver. So I'll just start it out from a steps perspective. The first thing you want to do is you want to find your pain points and criteria. After that, you want to identify your holy beacon of truth. We'll talk about that later. You want to go use case by use case. You want to make sure you're evangelizing. You want to be prepared to fight some of the really hard battles. And then the celebration, right? You want to shut down the old one and go out drinking. So as far as setting criteria is concerned, first things first, if you want to build your own monitoring system, if you have a good solution and you say, hey, I'm going to build out my own metric system, just don't. There are very few use cases where this is a viable option. And the reason being is because you have a lot of people that are way smarter than at least me when it comes to how to write storage layers. So I would definitely recommend not trying to build your own. So the next thing you want to do is you want to take a look and what are your pain points? Is it scale? Is it you built a system that's supposed to handle a few thousand metrics a minute and you're at 2 million metrics a minute and you're going to scale to 80 million metrics a minute? Is it a query language? Is it just the fact that you can't get some of the mathematical calculations that you want out of your metrics? Is it your ability to visualize? Maybe you don't have a good way to create dashboards, or you don't have a good way to really see and do anything with your metrics. Is it just usability? Does it just suck? Like let's say Nagios, for example, right? It just sucks to use. I think we can all agree on that. So that could be one of your big reasons. And also alertability. And this is kind of where I was talking about. You need to have a system that's going to be able to be smart enough to know that this is not something that you need to alert on right now. You need to have hierarchical alert structures. You need to be able to have very tailored and targeted alerts, because otherwise you're never going to get into that glory 75 to 85% signal to noise ratio. And then the other thing is, obviously, by the way, it has to be robust and scalable and all those other buzzwords that we all hear. That's just something you're going to have to take into account. The other thing is, don't expect buy-in once you've made your decision. You're going to say, okay, we've decided to go with Prometheus and our metrics are going to go through Kafka, and you want everybody to jump up and down and say yes because you're excited about it. You've been building it. The fact of the matter is no one's going to care until you start delivering. So a lot of people stumble here. They really think that once that they're going to get buy-in the minute they kind of pitch their solution. And most of the time that doesn't happen. The next thing you want to take a look at is identifying your holy beacon of truth. And so I'm going to just cut to the chase. This is service discovery, and it really is the foundation of your monitoring platform, because to keep your alerts down and to not get trash alerts, to not get thousands of emails, you need to know what to alert on. And the way you need to know what to alert on is by making sure you know what exists. So you can't decide anything monitoring related until you first decided what exists. And this is where Consul is really powerful, at least for us. I've implemented Consul at 2 organizations, and then at 1 organization, it was implemented for me, and I used it lovingly and adoringly. Long story short, it's really powerful to have a service discovery platform that can help you with this. It also allows you to really flesh out ownership, because that's going to be one of the big battles that you're going to fight, and I'll talk about that a little later. But right now, remember, the owner label that you put on in Consul is the most important piece of metadata you own, because it's who you go for. It's who you go to. It's where the metrics go to, and That's, if you're going to choose one piece of metadata to store, that's the one you do. You also want something that's going to be dynamic. When we add servers, when we remove servers, when we add new docs or remove docs, we need to know about that, and we need the system to be fully aware of all of the containers running, all of the services running, all of the servers running. It also needs to be complete. You need to have a full understanding of, what about network switches? Do you want to monitor them? Depending on who you ask, it might be valuable, it might not be valuable. But definitely services, definitely servers. You need to have a really complete picture. Also metadata support. Console is really good. It has the key value store, which we don't use, but it does have tags, which we do very well use. And you could possibly, depending on the scale of your environment, you could possibly consider having a secondary metadata store. We use Zookeeper as a metadata store, and we just kind of hook to a custom label in console. But at the same time, it really depends on your use case. We've noticed that console starts to act finicky. I've noticed it rather at other places when you get a lot of labels in it. So if you really want it to be very arbitrary and to be very finite, you need to be able to have a secondary place. But I think for the purposes of this discussion, I think that's a little bit too technical, let's put it that way. Also, a lot of you guys probably have Mesos or Kubernetes environments, and let's say all of your stuff in the perfect world runs there. It's still not enough. You might think, well, all of my stuff runs in Mesos, I can just use Mesos as my data. No, because you're going to need to have some place where you store metadata, and you're going to need to have some place where you can very quickly and easily get a full picture, right? Like when we talked about before, complete. We need to make sure that the servers are there. And Kubernetes may know about the servers that are running Kubernetes, but it won't know about services that are completely not containerized. We love console for this, by the way. It's really powerful. So the next bit is just go use case by use case. Look for modular, repeatable solutions and automate for them. And then the biggest thing that you want to do is seek out the easiest wins that are going to have the highest impact. If you have an easy win and an easy impact, there's no value there. Don't bother. You can put it off for later. You want to look for the easier wins with the higher impact, or the easier wins with the mid-level impact. So give Hadoop metrics to the data team, and then work through all of your pain points with them. Automate for some of those solutions, and then you'll start to get a good sense of what other problems you're going to face, and you'll be able to iterate your process of onboarding more teams onto your new system. And so when you want to do that, you want to be more customer focused, right? Think about your monitoring system in terms of somebody else. Think about your monitoring system in terms of the guy that's actually going to be using the monitoring system. The other really big benefit about this is every unique use case that you deliver, it gives you another person talking about you. And we're going to talk about that during the next slide. But the fact of the matter is you want people talking about you. You think they're not talking about you, but they are talking about you. So you want to have people talking as often and iterating on their conversations as much as possible. Like I said before, give teams like the ability to do it themselves. You're not going to handhold them through the process. Your job is not to monitor everything in the organization. Your job is to deliver a sane API so that people can monitor their shit. That's all they care about. That's all you care about. And no one's going to give you a problem if somebody's not going to monitor their stuff with your system. They'll give them a problem in the first outage. So this is the part that everybody hates. This is the evangelism part. This is because we're all introverted nerds who just want to solve interesting problems, right? So as much as we hate to do it, this is the one that's going to win you over the most easy wins, and it's going to let you recognize which wins are going to be the easy ones and which ones are going to be the hard ones. So definitely do demos and lunch and learns. Walk people through the process. I know it's going to be boring, but you just try to do it. It's going to be really valuable. The next one that I would recommend is definitely be in every single postmortem or take-in or whatever you want to call it. If there's a problem, you have to be there. You're the monitoring guy, and you need to be talking about that 300% metric that, hey, we would have troubleshot this, we would have figured the solution out 3 times faster if they had spent one sprint dashboarding. That's where you're going to be doing a lot of your evangelism, and most of the teams are going to ask you to be there. Most of the times that you're in a postmortem, you're going to be asked to be there. Make sure you're there and make sure you're present. The next bit is try to build highly visible dashboards, but then also make them highly visible, right? So when you start working on those easy wins that are high visibility, that everyone in the organization is going to use, you need to make sure that people use them after you've built them. There's going to be, like, if you just look at the graph of views on a particular dashboard, when you build it out and you send the first email of, hey, I have the new dashboard, it's going to go straight up and then straight down, and it's going to flatline. So what you need to do is when somebody says, how's the Kafka cluster doing? I think I have an app side problem. You don't tell them how it's doing. You send them the dashboard. You need to push them into using the dashboards, and you need to make the dashboards readable enough so that most users can understand them. Now, granted, there are some dashboards where inherently users aren't going to understand. Other teams aren't going to understand because this is a very unique, specific dashboard for a specific use case. Fine. But for the high visibility ones, make them highly visible. The next one is you want to use instantly recognizable units. If anybody's like a JMX guy, does anybody know what vCore seconds are? Hands? Okay, there you go. One guy knows. Yeah. So a vCore second is how many virtual cores you're using and for how many seconds you're using them. So I'm using 2 virtual cores and I'm using them for 60 seconds, which means I have 120 vCore seconds. This is a really valuable metric, and nobody knows what the hell those numbers mean. So you need to translate those into something people can understand. And the way to understand that, at least what we did, is we translated them into dollars, right? Because we know how many vCores each machine has. We know how many Hadoop servers we have. This is mostly like a Hadoop level metric. So we know how many Hadoop servers we have. We know how much the total cost of ownership of them is, and we know how many milliseconds there are in 3 years, and we assume that 3 years is the cost of ownership. So now, instead of saying your job takes 3 million vCore milliseconds or 3 million vCore seconds, I'm saying your job costs us $38 every time you run it. And last time you ran it, it cost us $76. So something got screwed up here. And instantly, you don't have to give these numbers to finance. You don't have to do anything with these numbers except for the fact that you're going to get people's minds around the very important concept of the units matter. If you remember math class in like 2nd grade. Absolutely, and the last part here is absolutely no new features or changes to old shit. So if you want something new, you get the new one, but we're not going to do any changes to the old monitoring system unless absolutely necessary. If the old monitoring system's on fire or there's some inherent problem, try to stray towards spending double the amount of time to get them onto the new monitoring system than you would spend building it, fixing the old one, right? Because in the end, the old one you're going to burn. And this is the one that I personally hate the most. It's fighting the hard battles. As you start to progress, you're going to start to bump into challenges about ownership, about developers receiving alerts. Some division of responsibilities are going to be another big factor that you're going to bump into. And my recommendation here is you definitely want to stay confident. You definitely want to be prepared for them. But you also have to remember that your job is not to get them to migrate. Your job is to get them is to give them a sane API. They're going to need to get themselves to migrate, and you cutting support for the old system is the only way that's going to happen. The other part of that is, with my experience personally, I don't know if it's like, I can't guarantee this across every company, but most of these types of like political battles start to fizzle out right around the 75% signal to noise ratio, because nobody has a leg to stand on. Nobody has a right to complain about alerts that are 75% accurate or 85% accurate. Most of the time, the people around them are going to understand that they're being a crazy person. You will find some people who are just inherently adverse to change. They just don't want to push themselves to change. And I mean, with those people, you're going to have a conversation with them, or you just let them ride on the sinking ship until the ship sinks, and that sinking ship happens to be graphite or whatever old monitoring system you have. And just some final notes. Be prepared to shave a lot of yaks. And what I mean by that is really boring, not interesting stuff that you're just going to have to get over. So couple of those is moving some alerts from the old system to the new system or translating them. There's going to be some weird inconsistencies that you're going to have to deal with. Long story short, if you expect that you're going to do annoying, not interesting work, let's say 10% of your project is going to be annoying, not interesting work, I think you can safely double that, and you'll still probably be under budgeting. But be prepared for it, accept it, and make sure that when you provide a solution, there are no one-offs. Everything is this is going to be a flat solution across the board for everybody that's going to do it from this point onward. But it is okay to iterate those solutions. The next big one, and this is one that I felt the pain on a lot, is stability is key once you start to deliver use cases. So the moment you deliver that first brand new Prometheus server or InfluxDB server to a team and let them start using it, the minute it goes down, all of your credibility is out the window. So you may feel like it's a POC and they're the first client of yours, but they're not. It's production. The minute a user is starting to get alerts on it, the minute a user is relying on your system, you're a production level system. So my recommendation here is really consider that when you're moving people over. Set expectations if you feel that your system might be a little shaky. And on the other side of that, it's not acceptable to have okay, we can all agree that a POC, if it goes down at 2 a.m., it's totally acceptable to like at 11 o'clock while you're drinking a beer to start to bring it back up, right? That's not the case anymore. Once it's out of that POC stage and people are relying on it, it needs to be, maybe you don't wake up in the middle of the night for it, but 7 a.m. it's got to be up and running in case somebody's going to be using it. Also, differentiate ephemeral metrics from key ones early on. Now, I'm not saying that all metrics are going to be ephemeral. This is kind of like something that I'm pushing for. But I am saying that your retention times will differ vastly by metric. Nobody cares about 5-minute load 24 hours from now. It doesn't make a difference. So try to identify the really valuable metrics, the ones that you will want to keep for 6 months or you will want to keep for 5 years, and treat them differently. Because you're going to bump into scale problems very early on, and you're going to really struggle with those scale problems. So if you can cut out all of the crap and only worry about scale problems for your important stuff, most of the time you won't even bump into those scale problems. And on that note, get a sense of scale early on. Understand, am I building a system for 1 million metrics a minute? Am I building a system for 100 million metrics a minute? It's a completely different environment. Also, try to compartmentalize your solutions. Try to give every team or every service a single compartmentalized solution. It's going to make your life easy because you're going to be able to scale horizontally really well. But also, it's just going to make the systems happier, right? Like I can give you a million reasons. We'll talk offline if you guys are interested. But when you do compartmentalize those solutions, you need to be able to share metrics. You need to have a single place where people can view metrics. Maybe they can't alert on them. Maybe they can't combine metrics for alerts, but at the very least, they need to be able to view them. And then the last bit is just talk to other teams. Fully understand what the other teams are, what their pain points are and what they need, and try to deliver according to that. And finally, just kill the old one and go out drinking. Like I said, that's actually, so this is probably, I can have a whole separate conversation about how to actually kill the old one and go out drinking. But yeah, I'm going to try to keep it. I think I'm over time anyway. So thank you guys so much. If you have any questions, I'm more than happy to help. And yeah, I mean, I can take any questions right now. Okay.
One sec, because we're recording.
Okay, so I would ask Squarespace, but I'm more than happy to send it to them, and if they want to put it up anywhere, I'm not 100% sure, but I can put it on SlideShare. Yeah? Okay, I'll put it on SlideShare. Okay, somebody.
Here you go.
You mentioned that the 300% savings after a 1 week sprint or a 2 week sprint.
2 week
That's
sprint.
what I was going to ask. How long of a sprint were you referring?
Yeah, it's a 2 week sprint.
Might be good to clarify that.
Yeah, so it's a 2 week sprint, and the way we calculate it is we do sprints by points, right? So we do like 5 points per person per sprint. So it's really hard to calculate a sprint because you can't just say all of the people together. So what we did was we took a look at how many stories teams had that had the word monitoring or visualization in it. And what we did was we took those and then we summed the number of points, divided it by the number of users, and then that's how we set the threshold.
Very good. Thank you.
Okay. Anybody else? Questions? Somebody?
How do you translate those accuracy?
Oh, I'm sorry. He has the microphone. I'm sorry. Go ahead.
Actually, it was the same sort of question as before with that very intriguing two-sprint metric. But so Grafana has like a reputation for being very easy to build out dashboards in, I gather, and Prometheus doesn't. So what was there a specific product that was being used when you got that metric?
We use Grafana. I love Grafana. I think I have a sticker. Yeah, I had a lot of trouble with using Prometheus like as a dashboarding system, but Grafana is really easy. We really like it. I definitely would recommend it.
So what criteria you use to translate those into the dollar amount? You cannot just randomly pull a number off the hat, you know?
Yeah. So like I talked about, you take the number of vCores each machine has. So let's say each machine has 8 vCores, right? And then you take the total cost of ownership of the machine. I guarantee you, finance has that number, right?
But not everything is vCore. It could be storage. It can be anything else.
Okay,
right?
so what my recommendation is, depending on the particular use case, you're always going to be able to say, I have this many gigabytes per machine, and this many machines, and then I can multiply and divide, right, by the number of machines, and I can still always treat a machine as a single unit. Remember, the accuracy of the number is not as valuable as the accuracy of the number in relation to of point A in relation to point B, just for this particular use case, right? It used to cost $38. If it costs $36.25, nobody cares. The point is that it used to cost $38, now it costs $76. And that's the difference that needs to be accurate, right? So as long as it's a linear line and it's somewhere in the ballpark, plus minus a few dollars, I think it's, I think you're pretty safe. Is there any more questions? Yeah. Oh, another question. Okay.
On the subject of migrations, are you talking about migrating historical data at all, or simply cut over between one current system and another current system where it's about users?
So when you are going to cut over systems, my personal opinion is that 85 to 90% of the metrics that you're going to use are ephemeral. You don't need them for 6 months. You don't need them for a year. So you can very easily just get rid of those altogether. And if you have some metric set that is going to speak a different language, you're going from Graphite to Prometheus, let's say, you may have some challenges there, but you're working with a fairly small data set that you could probably just call it a yak shave if you really need it. Or if not, you can just merge them in Grafana and call it a day, and then just wait for time to pass and roll it out. Anybody? I think we're good. Okay. Guys, oh, hang on.
You mentioned Nagios several times. I haven't been back to Nagios in years, but do you have specific pain points in Nagios you wanted to alert us to?
Oh, I mean, does anybody care about the pain points of Nagios? I will say this. Okay, so here's a couple of off the top of my head. There's no way to historically track any of the metrics. There's no way to sanely write metrics. There's no way to sanely alert on metrics that have more than 1 point. You're incredibly reliant. There's no way to hierarchically create those metrics, and you're incredibly reliant on like the stability of other systems to be able to read those metrics and to write those metrics. So I mean, I can give a whole talk about that. And by the way, when I say Nagios, I actually mean Nagios and Isinga and whatever they're calling themselves now. Anything that involves that old style of like, I am a service alert. I will go check the service. I will read the service's metric of from an agent that I have running. I will go alert on that. You need something a little bit more modular. You need something a little more modern, in my opinion, rather. Anybody else? No? Guys, thank you so much for having me. I don't know how to turn this off. Oh, why does it?
We have 5 seconds to reconnect. Plug it in. Oh, by the way, the Wi-Fi password is all things square on Squarespace guest network. Our second speaker is Simone Mainardi, and he's going to be speaking about real-time traffic monitoring using the ntopng tool. Is that on?
Okay. Okay, I think we can start now. Okay, hi everybody. Today we're going to see ntopng, which is an open source network monitoring software, but we are going to see the motivation behind the network monitoring, and then we are going to see the architectural design of ntopng along with its interfaces. And in the second part of this talk, we will see a couple of integrations, specifically with Grafana and Logstash. But before starting the discussion of ntopng, I would like to spend a few words to introduce you ntop, this company. ntop is a private company that has been around since 1988 and has R&D in Italy and sales in Switzerland. We have several products that are currently developed and maintained. Some of them are open source and some others are proprietary. And we cover several aspects of the network monitoring stack, I would say. We range from network interface drivers for accelerated packet capture. We have a proprietary technology which is called zero copy, that is basically a kernel bypass technology to increase the packet capture speed. We have ntopng and nDPI that are open source tools to monitor and do deep packet inspection. And we recently launched nscrub, which is a distributed denial of service mitigation software. So we decided to face the security market with this product after a couple of years of development. Finally, we also have N2Disk, which is a high-speed packet-to-disk software with the real-time indexing features that is useful, for example, for forensics analysis, lawful interception, this kind of activities. Okay, let's start seeing the software, ntopng. I would like to start this part of the presentation with a couple of quotes of Lord Thomson, also known as Kelvin. If you cannot measure it, you cannot improve it. Well, actually, this is true not only in network monitoring, but in many aspects of the real world. So why we might be interested in monitoring our network? Well, first of all, because visibility of your network can help you in diagnosing connectivity issues. For example, why the number of out-of-order packets is increasing? Why I am start seeing a lot of TCP retransmission for this host? Or, well, actually, I'm experiencing an increasing round-trip time or an increasing jitter. And you know, an increasing delay can become a bad user experience or an application that is slowing down. So network monitoring is important to have a real-time visibility of what is going on in your network. But there is more, I think. There is more because monitoring your network can also help you in detecting network usage that cannot be compliant with your network policies. For example, I have an employee that is doing BitTorrent at work. Why is he doing BitTorrent at work? That is a completely legitimate traffic from a network perspective. Everything is working okay, but why my employee is doing BitTorrent traffic? Is he downloading a copyrighted content at work, for example? Or my employee is visiting my competitor website. Why? Is he thinking to change job? Is he sending my proprietary data to a competitor? So network monitoring can help you not only in diagnosing connectivity issues, but also in detecting suspicious behavior that can happen in your network. Another thing is the detection of malware hosts. Indeed, ntopng is able to detect, has a blacklist of malware hosts. So as soon as someone that is using your network is contacted or contacts an host that is marked as blacklisted, for example, an host that distributes a ransomware, you will receive an alert, and ntopng will tell you, hey, this host, someone is contacting a malware host. So this is basically some of the motivation behind the importance of network monitoring. And now I would like to start talking about ntopng. But first of all, ntopng is open source and you can get it on GitHub. Currently, as of today, we have more than 1,200 stars on the project. If you don't want to download the source, you can get a binary version of ntopng. We distribute it for the most common Linux distributions, Debian, CentOS 6 and 7, Ubuntu 12, 14, 16, Raspberry Pi. We have Windows, FreeBSD, pfSense. Well, I think that they are almost all. So if you don't want to compile from the source, you can just apt get install ntopng and you're done. I would like now to discuss, to see the details of the architectural design choices we have made when developing ntopng. So at the lowest at the lowest level, we have kernel modules and network interface drivers that delivers network packets from the wire to an nDPI-based C++ monitoring engine. The C++ monitoring engine is basically the core of ntopng. We decided to use C++ to perform operations that are intensive. And indeed, for each packet, the C++ core does a series of operations. This kind of operation, for example, include this core keeps a real-time status of all the active hosts that are seen in the network and all the active flows that are currently seen in the network. I don't know if you are familiar with the concept of flow. A flow is basically a series of packets that share a common set of properties, including source and destination IP address, source and destination ports, and layer 4 protocol. So this monitoring engine keeps the state of all the active hosts and all the active flows in the network and updates counters and metrics such as the number of bytes transmitted by this host, the number of packets sent by this host, and so on. On top of this C++ engine, we put a scriptable layer because we wanted to provide a flexible architecture so that users can write their own scripts to implement logic, to implement an alerting systems, to implement custom reports without touching a single line of C++, without the need to recompile the C++ core. And indeed, ntopng uses this Lua scriptable layer to provide the monitoring results through a web interface. So ntopng has a web server that a user can issue web requests to obtain the data from the C++ engine through the Lua. We will see some examples in a while. So how is it possible to use Lua to pull the data from the C++ engine? We have basically a couple of mechanisms. So let's say that scripts callbacks and scripts Lua are two directories in the ntopng working environment. In the first one, you place Lua scripts that are executed periodically by the C++ monitoring engine. As you can see, we have daily, hourly, minute scripts. And we use these scripts to build an historical time series of all the active hosts in the network of the interface. The other way to execute a Lua script is to simply put it under script Lua. As I said before, ntopng features an embedded web server. So as soon as you start ntopng, you will have a web server running on your host on a given port. And if you want to execute a Lua script, what you have to do is just open up your browser or your shell with a vget or CURL and request the HTTP or HTTPS endpoint /lua/ the name of the script.lua. ntopng, we receive these HTTP requests. We'll start a Lua interpreter with some global variables, and we'll then actually execute the script. We have done several scripts that will respond with HTML content so that you can see the results of the monitoring in your web browser. But actually, it's more general. You can write your own script to write, for example, to respond in JSON or to just fire up a command without any kind of response. So how it is possible, this kind of interaction? Basically, ntopng defines a couple of, defines in C++ a couple of Lua classes, interface and ntop. Interface exposes the results of monitorings as concern the interface, the hosts that has been seen in the interface, and the flows that are actually active in the interface. While the other class, ntop, exposes general function and configuration information of ntopng. So it's very easy in Lua. You just have to say interface dot. These are two examples, but the first one gives you all the active hosts in the system, for example. So this call, this Lua call, will actually translate in a C++ method call that will actually pull out from the C++ engine the results of the monitoring. So I would now like to show you some examples of all these pieces, of how all these pieces work together. Let's consider this page. This is the web user interface that shows the active flows in the network. How can you access this page? You just have to point your browser to localhost 3000/lua/flow stats, and you will get a web page showing all the active flows that are currently active in your network right now. We have a series of data that includes the layer 7 application. So is it Facebook? Is it a YouTube flow? Is it DNS, Dropbox? We also have client and server hosts and port, the duration of the flow, the actual throughput, and a series of other information. In the last column is a general purpose column because, I forgot to mention earlier that the C++ monitoring engine also feature deep packet inspection. Thanks to the deep packet inspection, the engine actually dig into the packet payload to determine the real layer 7 application protocol. Doing application protocol detection on the basis of the destination port, it's pretty naive. We can simply say that this is an HTTP traffic because it's on server port 80, because anyone can run HTTP on a port which is different from port 80. So thanks to the nDPI, we actually inspect the packet payload to determine the real application protocol that is flowing in that particular flow. And we are not only able to tell you the application protocol, but we can do even more. For example, if the traffic is HTTP, we can extract the URL that has been requested. Or if the traffic is DNS, we can extract and show you the DNS request and response. Or if the traffic is BitTorrent, we extract the BitTorrent hash so that you can just grab that BitTorrent hash, put it on Google, and see the file that the user is currently downloading. So all this information are available and are exposed through the web interface. We can also select a single flow and have an even more detailed view of all the information related to that flow. This information includes, for example, the TCP flags. So if a flow is during its initial handshake with a sane SYNAC, or if the flow is in an established state, or if the flow has been reset, for example. You have also information on the packet inter-arrival time, on the good put, and a lot of other metrics. So this is the web interface. But as I said earlier in this presentation, this page is basically the result of the execution of a Lua script. So let's see how we can write a simple Lua script to extract data from the C++ core. In this very simple script, I used the function, the first thing that we can do to extract, for example, flows from the active flows from the core, the first thing we can do is just to call the interface class that we have seen before and say .select ATH0, because ntopng is multi-threaded and can monitor multiple interfaces at the same time. So you can say, okay, I want to select interface ATH0, and then I want to get all the flows of interface ATH0. But there's more, because we can pass also parameters to the function getFlowsInfo. For example, the first parameter is the IP address of an host, because passing an host there means, okay, I want all the flows that are active in the ntopng instances that have this particular host as an endpoint, so as a source or as a destination. There is also another extra parameter that gives you extra filtering criteria. So you can specify, okay, I only want BitTorrent flows of that particular host, or I want only flows that have a throughput greater than 0. So once you have the flows, you can simply, in Lua, iterate over the flows. This is a basic script that calculates the ratio of TCP flows that are in a non-established state versus all the flows, all the TCP flows. So this is basically a very basic script that shows you how to pull the data from the C++ core. Another view is the view of active hosts, which is similar to the flows. So you can get all the active hosts in the ntopng instance, extract a series of metrics of the hosts, and you can drill down into each particular host to have extra information. Extra information includes the MAC address, the manufacturer, SNMP information of that host. You see, there's a contextual menu over there that gives you a very detailed view of all the features of that host. Packet distribution sites, ports used, ICMP, ARP, an historical view of the host metrics, for example, application protocols, traffic sent and received, you have reports, you have a lot of other stuff. And all this stuff is available, once again, through Lua. And this is another basic scripts that show you how easy it is to extract hosts information from the C++ core using Lua. In this simple script, I created a function which is getTopInterfaceHost, which basically gets all the hosts that are monitored and sort them according to a decreasing order of the amount of bytes sent and received. But again, it's very easy in Lua. Just say interface dot the name of the method, and you have a scriptable way to do your own reports, to create custom alerts, and so on. Okay, now that we have seen a little bit the architecture of ntopng, I would like to show you the data integration with third-party tools. Currently, third-party tools supported are RRDs, Grafana, and Prometheus as a work in progress as concerned the time series data. If you are interested in network flows that actually are more detailed information of the network activities, then we support MySQL, MariaDB, Elasticsearch, and Logstash. And in this last part of the presentation, I will show you the integration with Grafana and Logstash. So, Grafana is a platform for monitor and chart your metrics. And I really like the design of Grafana because it's so modular. I mean, the plugin architecture of Grafana allows you to abstract from the storage so that you can get charts and you can create dashboards. It doesn't matter if you use InfluxDB, Prometheus, ntopng, Druid, or whatever. You can get the data and visualize the data. And it also provides very flexible visualization with shareable dashboards and reusable building block, which are called panel plugins. So I wanted to integrate ntopng with Grafana. So I decided to expose some basic metrics of interfaces and hosts. These metrics include throughput and application protocols. And to do this integration, I reused the simple JSON plugin by Grafana Labs. That plugin was not supporting authentication, so I forked that plugin and I sent a pull request to the Grafana team for the authentication. Those are the metrics that are exposed by ntopng to Grafana. As we can see here, we have interfaces and hosts traffic in bytes per second and packets per second, as well as all the application protocols of an interface or of an host. But let's see a real use case. Let's see how we can create a Grafana dashboard out of ntopng data. The first thing to do is to actually add the ntopng data source. So you just have to go to Grafana, add the data source, select simple JSON, give a name to the data source, and specify the URL. The URL, maybe we are familiar with this kind of URL. As you can see, we have IP address and port /lua/module/Grafana, because this Grafana will try to contact that endpoint that will in turn execute a Lua script to provide data to Grafana. Then you have to tick basic authentication and set a username and password that are of a valid user as configured in ntopng, because ntopng has a web interface that requires authentication to be accessed. So you have to use the same user there. If everything works, you can just hit save and test, and you will get a success information. Okay, let's now see how it's possible to add panels to a dashboard. For example, if I want to, you can simply start typing the name of the metric in a Grafana input to get the auto-completion show you all the available metric that match the input text. So let's say here that we want to create a graph to show the traffic of my network interface monitored by ntopng. I can simply select the metric, and I will have then to specify the unit of measure for the axis, which is in bits per second, and I will just give a basic title to the graph. So as we can see from this slide, we have the Grafana chart on the top, and we have the ntopng chart in the background of the slide. As you see, those two graphs are identical, but while the chart at the top is in Grafana, the chart in the background is the chart shown within the ntopng web interface. We can do the same thing this time to show, for example, a stacked chart of all the application protocols that has been seen in ntopng. This time, we will have to just select the metric name as interface and 0 all protocols this time, and just tick the stack checkbox in the display. Again, we can get the Grafana chart on top that shows, for example, the interface activity, which is Ubuntu One and SSL, and we can compare that chart with the actual chart as shown within the ntopng web interface. And as you see, those two charts are identical, but once you have the data in Grafana, you can reuse the panel to build your own dashboard and to integrate with your own data sources. And if we want to put all the data together, we can get a dashboard like this one, where we have total bytes and packets, for example, but we also have average values and the trends in time of traffic and packets, as well as a stacked view of all the application protocols of the interface. So again, this is all data pulled out from the C++ core of ntopng through Lua and provided to Grafana. The other integration that I would like to show is the integration with Logstash. You know, Logstash is a pipeline to ingest data and to augment and transform the data and eventually to downstream the transformed data to one or more stashes. So stashes such as Elasticsearch, MongoDB, HDFS, and so on. So how does ntopng delivers the data to Logstash? It basically asynchronously delivers flows data to Logstash as JSON over a network. So every time a flow is expired and every time ntopng detects that the flow is expired, it will send through a TCP or UDP socket the expired flow to Logstash. So this is a basic Logstash pipeline configuration that shows how to integrate ntopng with Logstash. In the first part, we have an input, and we say we want Logstash to create a TCP socket, and we want Logstash to listen on that particular host and on port 5510. But we also have to tell Logstash that it has to expect JSON data in that particular socket. I didn't specify any filter here, and as an output, I just redirected the flows received from ntopng. I redirected them simply to the standard output of a console. In practice, you will have to send them to Elasticsearch, for example. Once you have this configuration file, you can start Logstash. It's very simple like this, bin Logstash, then you specify the pipeline configuration file and the path settings, which contains Logstash general configuration files. And then as soon as you start Logstash, you can confirm it is listening. And indeed, there is a TCP socket listening on port 5510 in that particular host. So now you can start ntopng. It's very simple also how you can start ntopng. You specify the interfaces you want to monitor, for example, EN0 and low0. And then you tell, hey, ntopng, I want you to deliver data to Logstash in that particular IP using protocol TCP and port 5510. As soon as you start this, you will start seeing flows popping out in the command line. And this is an example flow that has been received by Logstash. But of course, you will see many of those flows appearing in the command line of Logstash. And in practice, you will send them to Elasticsearch or another storage. So, okay, thanks for your time. I think I'm running a little bit late, but yes, we have seen the details of the ntopng architectures and some of the ntopng integration with third-party tools. Oh, okay. So thank you if you have questions. Sure. No, that has happened before.
Okay, so if you plot something behind the table.
Yeah, sure, yeah. Sure. We support BPF syntax in ntopng. Sure. Yeah. We have traffic profiles that are dynamic. You create a traffic profile by specifying a BPF filter, and then as soon as you specify the BPF filter, you will be able to create metrics and time series of the traffic matching that particular filter. You will be able to see this kind of information. Yeah.
And on the ingestion side, does it require the PF ring? And if so, does that require a custom kernel module or something? I'm not sure about that.
PF ring is not required, so you can use standard lib pickup. But PF ring can achieve higher speeds if compared to standard lib pickup. So I would say if you want to go faster than 800 or 1 gig per core, then you have to use PF ring. You can also reach 4 or 5 gigs per core per second, but in that case you have to go with PF ring zero copy. PF ring zero copy basically does not copy packets from the kernel space to the user space and just uses pointers, and this makes it a lot faster.
But that's a kernel module you have to install. That's like an extra step to set this up?
Yeah.
On the PF ring, is there any thought about supporting or anything to do with Intel DPDK, which is functions, I think, very similar to PF ring?
I know that my colleagues have done some works towards the support of DPDK, and I think it's under active development right now. Yeah.
One more thing. I think you mentioned, one of your slides had SFlow mentioned. Can you export flows as SFlow protocol or NetFlow protocol?
We don't. ntopng does not talk NetFlow or SFlow because in the design choices we made when creating ntopng, we decided to decouple all the implementation of flow technologies such as NetFlow, SFlow, IPFIX, and all these kind of technologies. We decided to decouple them from ntopng and put these technologies in nprobe. So we have another software which works together with ntopng, but it's different, which on the one hand can interpret and talk with your NetFlow or SFlow devices. So if you have hundreds or tens of routers or switches that do SFlow, you can use an nprobe and collect all this data. But you can also export this data in a plain JSON format or towards another SFlow or NetFlow destination. So you can do that. You can do both. Read and export. And it's supported SFlow, NetFlow, version 5, 9, and 10.
And that's with the nprobe part.
That's the nprobe part. But nprobe communicates with ntopng using a simple JSON over 0MQ. So you can use nprobe to collect NetFlow data, and then you can use ntopng for the visualization of the collected data, simply over 0MQ.
Can you speak to the specific test cases for using build your own? I think we the previous hour we were saying build your own is inherently risky. Are there specific test cases for ntopng that really warrant people to build their own monitoring.
Do you mean to build your own extensions? What do you mean to build?
In terms of going from a package solution to an in-house solution that exploits the features of ntop ng. Sorry.
No, I'm not sure to get a point. Can you please try to say it again?
Sure. It's essentially if I were to go out in the open market and say I need a monitoring solution versus I need specific features for my application or my implementation. Does ntop ng offer particular features that would warrant me to build in-house a solution for monitoring or for reliability?
I mean, you can build your own in-house monitoring solution. ntopng, thanks to nDPI, supports more than 250 application protocols.
That's really what I'm getting at. Is do you have use cases in particular that are kind of pointed towards a recommendation of ntop ng over package solutions?
Yes, I mean, we have several customers that use ntopng in real scenarios. For example, large telecom providers that wants to monitor the traffic of their users to see if the traffic is legitimate, for example. And thanks to the DPI, you can, with more than 250 protocols, you can actually, we basically support all the most common protocols that are in the market. So it's a flexible solution to provide this kind of solution.
I'm actually interested a little bit more in the capture side of things. So this might be an nprobe question, but so I'm interested in capturing data from a number of servers and actually capturing the full packet flow and doing analytics based on that. So does ntop ng allow me to somewhat orchestrate what data I'm collecting from each agent?
Sure. nprobe together. So basically, the nprobe, you can install one or more nprobe agents close to your servers. This is up to you to decide where to install the nprobe agents that actually monitor the packets. You then have a flexible way to specify all the metrics that you want your nprobe to export to the ntop ng. So there is a templating mechanism available in nprobe that allows you to specify all the metrics that you want to be exported to the ntop ng. And that includes the IP address of the server that is being monitored. So on the ntop ng side, you will be able to create virtual interfaces. One virtual interface for each monitored server. So you have a single instance of ntop ng that gives you the flexibility to monitor tens or even hundreds of network interfaces, each one that actually correspond to a physical server monitored somewhere in your infrastructure. You can also merge virtual interfaces together using views, because let's say that you have 10 servers in your finance department and you want to aggregate all the finance department data together, then you can create an interface view that merge together the data monitored from all these 10 servers.
So just to follow up there, I guess my question is a little bit more, I want to control from a central point what services I'm actually capturing packets from at the point where the nprobe agent is installed. So I'm in a cloud. I don't have access to a network outside of my operating system essentially and the interfaces that are connected to it. So I want to be able to capture, say, port 80 traffic from my web servers. I want to capture various points, various types of traffic from my database servers, but I don't care about database backups, so I don't care about those ports. I'm only interested in capturing, not for pure metrics purposes, but I'm actually interested in the packets themselves.
Yeah.
Is there a way to control that from ntopng?
I mean, you have to control from the ntopng. You can use, for example, BPF filters.
Okay.
But I would recommend controlling this information on the nprobe.
Okay.
Because so you reduce the amount of processing and traffic if you can inject the rules directly into the nprobe.
Yeah, I guess I would just want to push it from a central place.
No.
Right. Like
no.
Got a container environment, and I want to be able to push that from a central. Okay. Thanks.
Yeah.
All right, so you stick around for more questions, Simone?
Yeah. There was one more.
So the deep packet inspection happens in C++ on the nDPI layer, right? If you didn't want to use Lua and you wanted to be at a lower level, do you still have the ability to do custom things there? And then is what's exposed in Lua kind of a watered down version, or do you have access to everything that you would need to in sort of a general way?
No, in Lua you have access to everything. I mean, the outcome of the deep packet inspection is accessible from Lua. So the protocol, like, me take. Okay, see here we have protocol TCP HTTP. This is data pulled out from the C++ core. So you have access to the HTTP protocol. But not only to the HTTP protocol, but also on the HTTP information. See at the bottom of the page, you have the method, which is get. You have the server name, which is localhost, the URL, and the response code. All this kind of information is extracted using nDPI and is exposed to Lua.
And so what if you want to write like your own protocol inspector, like custom?
You want to write your own inspector, you have to write a part of the nDPI library. nDPI library is open source, and we have actually a lot of contributors because people sometimes have their own proprietary protocols that are not disclosed sometimes, or they are disclosed, but they want to write their own dissectors. So you write your own dissector in nDPI library, send the pull requests, and we evaluate and integrate that request in the library. The library nDPI is used in nprobe, is used in ntopng, and we have a lot of customers and partners that integrate nDPI in their own custom product. But yes, you can write your own dissector, send the pull requests, and you will have it integrated in the library and thus in ntopng.
Thank you. Sounds great.
All right, thank you, Simone.
Thank you. Thank you.
And thank you all for coming. There's still more food and more beer, and we can stick around.
We have keychains, stickers here, so if you want, feel free to grab one. Thank you.